Hello everyone, welcome to another episode. This time around you're wondering what I'm doing up here. Today is going to be our site walkthrough interview, and we're not having the managing director today. He has so many other things available for him to do. So I'm going to be interviewing the site engineer, and the site engineer is going to be taking us around the site. Also, this is the Belmont project, and it's a commercial building, not a residential building like the other one that we did. So this is a commercial building, and we're going to be learning a lot of things, from the slab to the planks to the columns to the piles to the ground beam to concrete, and also to a lot of things the site engineer would mention. So stick with us on this video, and if you have any questions surrounding that, I'm sure the site engineer would be available to answer us. My name is Favor Orok again, and I am your moderator. Okay, to be a site engineer on a big site like this,
okay,
or let me rephrase, to be a site engineer on a beautiful site like this, what does it take to be a site engineer?
Okay, thank you very much. My name is Damlola Steven. I'm a site engineer at Belmont Residence, Akokayaba. So this project is a first suspended floor project, and it is on pipe foundation. Yeah, so to be a site engineer, it has to be someone that you have a degree in engineering, and not just a degree in engineering, you have to be someone that have practiced at least 2 internships, mentored under someone. So being a site engineer on this project is you being able to, like, the intents of the clients on paper, you interpreting it on site. So that is one of the main functions of a site engineer, while ensuring that quality assurance, quality control is fully implemented. So that's one of the things the site engineer used to do.
So from what you mentioned that this project is a force suspended.
Force suspended.
So what does that mean?
Okay, for a force suspended project, that means like right now we're on the ground floor for this project. Okay. So like we are standing on the ground floor.
Yes.
So the force suspended is after you climb your staircase, the first one, then you climb your staircase to the second one, third one, and the fourth one.
So that's like a 3-story building.
Like a
4-story building.
Yeah.
Oh, wow. So at some point when this project started, I mean, you were there from the beginning of the project.
Yeah, I was there from the foundation, yeah.
So what were some of the things that you took cognizance of as a site engineer? What's that one thing that must be available?
Okay, thank you very much. From the foundation process, because this is a pipe foundation.
Yeah.
And any building that why do you use a pipe foundation? The essence of using a pipe foundation is that from the geotechnical reports, you've seen that the soil in this place is kind of a weak soil, and in order to carry the load, we have to transfer the load to a stable strata. That's why we are using a pipe foundation. And one thing that we have to be very careful of while working on the pipe foundation is that you have to ensure that the pipe cap, because the pipe cap is like a base that helps to transfer load evenly to the piles. Like we can have 6 piles on a point. So the pipe cap is one that connects everything. Everything together. So in terms of the reinforcement for the pipe cap, the bar spacing, it has to be in line with what is inside the structural drawing, because anything that is going to, if there's any mistake at that point, is going to affect the load distribution, and that may lead to failure. So the foundation phase is actually a very crucial phase in a construction like this one. This is something that one must ensure that quality is followed. You follow instruction as it is specified in the drawing. In fact, there's no construction that you should do if there's no structural drawing. And every phase that one is doing, you have to carry your structural engineer along. You know, in a project, you have the site engineer, we have the structural engineer. It's the structural engineer that will give us the details, like use this number of reinforcements, use this diameter of reinforcements, space your bars like this. My own job as a site engineer is to interpret that on site. And there have also been situations like that, like when we're working on this particular project, due to some obstructions we had inside the soil, because once the soil test report should give us, we are drilling 11 meters down. We may be drilling the pile, and at some meters we see a very big rock, so we have to move away from that point. So as we've moved away from that point, there's already a slight change already.
Okay.
So in that kind of scenario, you have to like relate back with the structural engineer. You understand?
Yeah.
So after relating back with the structural engineer, so we experienced one of two issues here on this side. So when the structural engineer did this design, it was like, okay, increase the weight of the pie cap. There was a pie cap that we had a rectangular pie cap before. So from a rectangular pie cap, we changed this to a square pie cap, and about 2 of them on this side. So those are the things that you have to watch out for in your foundation. There has to be that collaboration during the foundation process.
Now you've been mentioning the word pile. Pile that me I know is that one that they take to the hospital. You know, this person has pile, and I don't know how it's going to be related into construction. Now, talking about pile, is this something I can see?
Assuming we are here during when they were dealing with persons, but for now, it's not something you can see.
Oh, for now, it's already inside the ground.
Inside the ground.
Oh, I thought pile is something that would uphold the building, something like that. Is it the kind of stuff that they put iron in the ground, then they cover it with cement and all those kind of things?
Okay, let me just explain what a pile foundation is.
Okay.
Basically, so a pile foundation is a type of deep foundation. And like I said earlier, a deep foundation is very used when the soil has a very low bearing capacity. Okay, like that's after your geotechnical investigation. Before any project you start, the first thing on the site is that there has to be a soil test. That's the first thing, and this is from the soil test that give us that, okay, with this particular project we are using a pile foundation. So now from the structural design, okay, let me just put it inside this way like this. Now let's assume that from our structural design, from the geotechnical report, okay, the geotechnical report will say use a pile of depth of 11 meters. Okay. And the 11 meters can carry a load of 1,000 kilonewton. 1,000 kilonewton. And the pile is always a rising circular piles. Just imagine a column. Circular in nature. And we are drilling it 11 meters into the ground. So once the column should reach 11 meters into the ground, it can accommodate a load of what? 1,000 kilonewton. You understand?
Yes, I get it now.
Okay, now, so by the time we put all our building, we put all our floors after the structural design, and the load coming from this column, you know, this is a ground floor columns now.
This is a ground floor column.
Now, these are the columns that will transfer all the loads of the building to the foundation.
Like when you mean load, like load distribution of this is the sitting room, this is the room, master's bedroom, kind of.
Yes, you know that all these the sitting room, the master's bedroom, this is a commercial building, it's a short-let apartments.
Okay.
Yeah, so dead loads, life loads, loads of everybody. Okay. The column, everything is being transferred from the slab to the beams, to the columns, to the foundation. So these ground floor columns are the ones taking everything to the foundation. Oh wow. Okay, now let's imagine that, okay, as this, by the time the load distribution has been done, this the load coming on this column, let's say is 5,000 kilonewton. Okay. Now I know that your one pile, if you drill it down, is taking 1,000 kilonewton. Okay. So how many piles do you need to carry this column? It's just to divide the load coming
so this column
divided by the load that the pile can carry. That's 5,000 divided by
okay. It seems if someone is not good with mathematics, you cannot do this.
You can. So apart from, like I said, so 5,000 kilonewton divided, so we have about 5 piles that are holding these things together. So now, but the thing is that, you know, I was saying something about pile cap. So the pile cap is like, let's call this like a tabletop, because the piles are like columns 1, 2, 3, 4, 5. So you need something to evenly distribute the loads to each one of them. So that's why we have a pile cap. So this column, as it is coming, transfers the load to the pile cap. The pile cap transfers the load evenly to the piles. So that's just the basic principle of how pile foundation works. And there's one other thing that you have to note in pile foundation, and that's our ground beam. So the essence of the ground beam is to tie all the pile caps together, because definitely
tie all the pile caps, the ones that we cannot see, right?
Yes, the pile caps are already inside
the ground. So the essence of what again?
The ground beam.
Of the ground beam is to tie all the pile caps
together. Because we'll do it in the case that, because during construction construction, from the
Yes.
foundation, because we have to consider that there may have been some little deviations due to site conditions.
Okay.
So the essence of using the ground beam is to ensure that everything works as a uniform structure, so that even if this one, if the pie carpet, there have been some adjustments, if it wants to have issue,
Another one is already
tying it down. This one is tying. So everything is working as one. So if there's a problem with one, everybody will share the whole problem together. It's not like one will not be stressed and be leading to failure.
And so that will also have to come with its own calculation.
Oh yes, it has to come with its own calculation. Everything that has to do with structural has to do with calculations. It's not just, there are codes that are backing it up, but there are structural calculations and these are the outputs of the calculations. Use this number of reinforcement, use this depth of pie cap. So that's how it works.
So I've been seeing on construction site, I've seen series of stuff like this iron. What's this called?
These are reinforcement bars.
Reinforcement
bars.
Bars. Okay. So there are situations where instead of using this, they use this.
Yes.
Why is that so? Okay,
thank you very much for that question. So everything boils down to the design, the structural design. Okay, now this is like 10 mm reinforcement bars now, and we probably use this one mostly for our links. These are our steel to tie it together. Like now, if you check these columns now, these are 16 mm bars. Even some have 20 mm bars. So each column have different loads that they are transmitting or that they are carrying. So what we are doing is that we are going to provide reinforcement bars that can transmit those loads. Hence, reason why we use different ones for different functions.
Okay, so it boils down to the fact that the load distribution has to determine the type of reinforcements that we are going to use. Okay, now aside from this, I've seen this one. Now, if this is strong, this is a column, right?
Yeah, this is a column.
This is a column. Now, why do they have to use wood? And this time around, they're not using just any kind of wood, though. They're using very strong wood to hold this together, and then using another iron to hold it down. Why?
Okay, thank you for that. So for this one now, what you are trying to achieve is a reinforced concrete element. Now,
reinforced concrete element.
So now we have two words there. Yes. Reinforced concrete. It comes from reinforcement. Reinforcement and concrete.
Concrete, is it something like this?
Yes, concrete is something like this. So
like, is it the same ratio of mixture?
No, it's not the same ratio of mixture that we are going to use for this, that we are going to use for this.
Yes, okay.
So I'm still going to talk about that one later.
All right.
Now, for the reinforced concrete elements, that is a combination of reinforcement and concrete. Like now, these are our reinforcements. So in order to have our concrete, now that's why we are making this formwork. And the main reason that we are using this type of formwork, this marine board and HOD, is to ensure that we have a perfectly shaped formwork. And the essence of this one is to properly blaze it, because as it is like this, you are going to vibrate this. During casting, you are going to vibrate, and the essence of vibrating is that you don't want to have honeycombs. Honeycombs in the sense that by the time you remove this formwork, you'll be seeing holes in the concrete.
What does it mean to vibrate? Like, is it the literal vibration?
Yeah, that's how it is. But there's a machine that we call it the poker vibrating machine. So why casting this?
Wait, what again? When you say casting, like you're going to cement this together with the column?
And yes, we are going to pour concrete inside. So the operation of pouring concrete inside this is called the casting process.
Okay, so it means that the concrete cannot leak out of this hole.
No, the concrete can't leak out of this hole. So that's the essence of doing the formwork. To ensure that once you pour the concrete, everything stays inside together.
Oh wow! So once the concrete is inside it, and then after drying, like for how long is it going to be?
For columns, after 24 hours.
Wow.
We have to remove it after 24 hours.
But is it going to stick together within 24 hours?
It's going to stick together after 24 hours. The curing process will start by that time.
But you know that thing is always very thick.
Yeah.
So you want to tell me that after 24 hours, I can remove this and it's going to stay together?
Yeah, for column. It's not for all structural elements. These are vertical structural elements. For column, if you don't remove
there are different kind of elements.
There are different kinds of elements.
Okay, please mention Another one.
You have columns, you have beams, you have
Okay.
slabs, you have retaining walls, you have culverts, you have a lot of structural elements. But for this particular project, you'll be working with, after our columns, the next thing you're going to have our beams. Then we have our slab.
Okay, and each of them have different ratio of how they are going to like dry.
Yes.
So
for this one, 24 hours, because if you don't remove it after 24 hours, there's a possibility that the bonding between this concrete and the wood, this will not be able to be used again. Like it's
this wood will not be able to be.
Because by the time the bonding with the concrete will have bonded with it so much that the process of removing it can actually destroy this particular
Now I guess it. Now, but my question is, how do you guys know all these things? Like, what? It's so amazing. I mean, so after 24 hours, you're going to remove this.
You're going to remove this.
So after removing it, like for how long will the concrete be allowed to like dry up on its own?
Okay, yeah, the concrete gains its maximum strength at 28 days. 28 days. So for this particular column now, there are different methods of curing. But for a column, once we remove the formwork after 24 hours, you are going to wet it with water.
Why exactly? So why is it that, let me start from blocks. Now when they bring the blocks, why is there a process of wetting those blocks?
Yes, the essence of wetting those blocks, actually during making them and while it is on site, is that to reduce cracking. You know that definitely in every concrete element that we do, there's always cement in every concrete element. And cement, actually, the type of cement you are using, it dries up very fast. So you understand. And once there's like a fast absorption of water, there's a tendency for it to crack. So in order to like reduce the cracking, immediately we remove is to pour water on it, so the concrete absorbs the water. Then after pouring water on it, we tie a cloth around it. The essence of tying the cloth around this is that the cloth will retain the water. So this will be curing, it will be absorbing the water little by little, and it will be gaining in strength over time.
Now, you know, in construction, I have heard that water are of different type. There's hard water, there's soft water. And in one of our episodes, we mentioned that we don't use any kind of water for construction. So you don't use like maybe a dirty water, because it is water, you can use it for mixture.
Water that has impurities, and we don't use water that has impurities. And we also don't use water that have high salt content. Salt and concrete, they are enemies. Salt can eat through concrete. So
how do you test the water also?
Yes, we test the water.
Wow.
To know the type of water that we use to mix
on a lighter note, you said salty water, right? So if I use this salty water to cook rice, do I need to add salt to the rice?
Salty, I don't know.
So let's talk about this iron. Is there a name for it?
What's the name of this iron? These are acroprops.
Acroprops.
Yeah, they are used for brazing, for the structure, for these columns. Acroprops. And like I said, the essence is that, you know, by the time we are casting this thing, we are going to vibrate it. And during vibration, we don't want the vibration process, we want to burst this formwork. That's why we are using this one called copper brazing.
Acroprops.
Yeah.
Okay, so for every kind of holding, must it necessarily be this type of iron?
No, there are definitely different types of for us to do our column formwork process. There are different methods that we can employ in order to do it. Some don't use this, but you know, at realistic projects, we care more about quality, we care more about standards. So this is a very high standard method of doing the column formwork. That is why we are using this on all of our projects.
Oh wow. So you were explaining the other time about the ground beam holding piles together. So how does it work for this type? I mean, how many pile is holding this? How many ground beam? Like, how does it work here? Okay,
thank you very much. So, like, no, I said this before that we have some columns we have 5 piles, some columns we have 2 piles and everything. So for this particular column that is here, we have about 2 piles that are holding this particular column.
2 piles holding this particular. So is it? Can I say a rough estimation that there are more than 20 piles?
Yeah, we have about 64 piles.
Wow. I'm saying 64 piles.
We have about 64 piles on this particular project.
Oh, wow.
Yeah.
So now, another question I want to ask is, aside from the Belmont project, any other kind of project, must it be exactly the 64 piles, or it has to be that after the soil testing will determine the amount of piles that will be used?
That's a very nice question. The thing is that for every other kind of project, like, is the nature of the soil that will determine the number of piles, and the type of structure that is coming on top of that land determine the number of piles. We can take this same structure to another site or to another land, and yes, it's requiring 64 piles. On other sites, it can require 50 something piles.
Oh, wow.
And on other sites, it may require 100 piles. And it's the same load that is coming, but the bearing capacity of the soil leads one to determine the number of piles that we are going to use. So the factor that determines the number of piles that we are going to use on a particular project, the soil bearing capacity, and the load of the structure that is coming on top of the soil.
So we're talking about water the other time.
Yeah.
Now this is the rainy season.
Yeah.
How will let's say, for instance, let me put it this way. For instance, rain starts falling and then you've already mixed your ratio. I mean, there's a different ratio you use when you're casting, and there's a different ratio you use when you're doing your foundation, right?
Yeah.
Okay. So now that this is rainy season, and then let's imagine rain starts falling. How do you handle the mixture of water with the ratio? How do you handle water not getting into the columns? Or rain can enter.
Rain can enter the column.
Rain can enter the column. Okay.
I think the process, I think I'm trying to understand what you're talking about.
Yes, exactly. I'm grateful you understand.
When you're actually mixing the concrete, the thing is, after we pour the concrete norms and if rain should fall, it's actually better for us, because definitely the concrete will be curing. One of the methods of curing concrete, curing is when concrete is actually gaining in strength.
Okay.
For the concrete to be absorbing water. So if we cast and rain falls, good.
Perfect for you.
Perfect for us.
But what if all this very heavy rain? Perfect.
It's still perfect.
Really?
Depending on the structural member.
Okay.
Again, the thing is that once you cast and the concrete should set, like after some hours it has set, that means it is already adding a little, and rain should fall. It's still okay. But one of the things that we have to be very concerned about, especially if rain is falling, is that if our cement, because we have, if rain falls during casting, there's every possibility that it washes the cement away. That's where these are some of the things we face on site, and that's where some engineering judgments will come. We always have a water cement ratio during specified by the structural engineer, and that we use to cast. So anytime rain should fall and it washes the cement away, the thing is that the existing mix is to add additional cement to the existing mix to ensure that the strength is still maintained and continue to cast.
Oh wow. So let's dwell a little on that ratio thing. Growing up, I like to smell cement. So I don't know, there's just this weird feeling I like from it, and I like to touch it. Now I heard that cement used to eat the flesh on your palm. Why is that?
Cement is a combination of different chemicals that used to make cement. And one of them is lime, the limestone. So we eat limestone to make clinkers and everything, all those chemistry process. So definitely there are a lot of chemicals inside it, and some of them are flesh eating chemicals. That's why anytime you are working on anything related to casting or cement on site,
wear gloves.
You have to wear our gloves.
Oh wow. Okay, so where I'm going to is the ratio of cement, granite, and sand. The other day I was at I think it was the Jeva project, and I saw the way they were mixing. So at some points they will pour 2 trips of sand. Is it 2 trips? A bit 2. What was the 2 headpan of sand? Then they'll pour 4 cement. So what's the ratio like for foundation? What's the ratio like, and what is the determinant of it? Is it also still the soil testing that is going to determine the number of cement you're going to use when you're mixing during the ratio? Is it like the kind of mathematics ratio we used to do, that 18:20, then you divide 2 and divide 18, 2 and divide 20? What's the ratio like?
I understand. So for that particular thing, to determine the ratio of cement and concrete that we are going to use, it depends on the strength of the concrete that we are planning to achieve. achieve. We have different concrete grades.
Okay.
And different concrete grades will determine the ratio that is going to achieve that concrete grade. We have concrete grade of 25 Newton per millimeter square.
Okay.
Then we have the higher it goes,
Yeah.
the higher the stronger the concrete.
Okay.
So we have C20, C25, C30. C30 means 30 Newton per millimeter square. That's the compressive strength of the concrete.
Oh,
now,
wow.
now talking about the mix ratio now.
Yes.
There are different types. There are two different types of mix ratio. We have the nominal mix and we have the design mix.
Okay.
Now, the nominal mix is like, over time that people have worked, they've known that, okay, if we use this particular mix ratio,
Yeah.
we will get grade 30. Now, for grade 25 now, like you said, I saw people pouring one,
Yes.
so
Yes.
we use the ratio of 1 to 4.
1, 2, 4.
From that, so you're going to get grade 25. That's 25 Newton per millimeter square compressive strength. That 1 to 4 means 1 earth pan of cement to 2 earth pan of sharp sand to 4
Okay.
earth pan of gravel.
Okay.
Yeah, that's it. Now for
1 earth pan of cement.
yeah,
2 earth pan of sharp sand.
So we have to 4 earth pan of
4 earth pan of gravel.
yeah.
That's for nominal.
Yeah, for the nominal. That's the nominal mix. For the design mix, sharp sand in Lagos is different from the sharp sand in Abeokuta.
Oh, wow.
It's different from the sharp sand in. They both have different content and everything. So the design mix is that they are going to take each of those constituents to the laboratory.
Okay.
So they will now do some tests. They call it concrete mix design.
Oh, so aside from soil testing, there's also concrete mix design.
Yeah, so they will do the concrete mix design based on the materials that are available on site. So from that concrete mix design, they will now give us, okay, instead of using 1:2:4 to achieve 25 Newton per millimeter square.
Yeah.
Because of the materials you have on site, if you use 1:2:4, you may not achieve that.
Oh.
Okay, you have to use 1.75,
Okay.
based on the materials that we have on site.
Yeah.
But for most of our projects, we work with the nominal mix for the concrete.
Okay.
These are marine boards.
So let me ask this question. Now, water and wood don't work well together sometimes. I don't know if it's for all kind of woods. There's some woods that once water touch them like this. And from one of our episodes, Mr. Adebayo Giwa mentioned that there are some woods that when water touch them, they will start either contrasting, expanding, and some of them will start bringing out fungi. That's because maybe some of those woods did not dry.
Did not dry well, and there's no proper treatment.
Okay.
There are several treatments that must be done on the wood. Definitely this is Nigeria.
Yeah.
To cut cost and everything.
Now, looking at this wood, this is the wood that you use for the column.
Yeah, the formwork of the column.
Now, my question is, when rain falls, how is it that this wood is able to survive all of those expanding, constructing, bringing out fungi, or it doesn't survive because after the usage is meant for firewood?
No, after the usage of this one, something about this is actually a very durable wood. We have a marine board. The thickness is actually quite strong and it's quality material. But one of the things of it is still a wood material. It's still a wood, it's still a plank.
Yeah.
So after we have used it, we are going to properly store it to ensure that it is not, water is not actually pouring much on it. It has the ability to retain water, like to absorb water. But definitely it must not be too much.
It means that this wood is very, very durable.
Yeah, it's a very durable wood.
So, are there any other kind of wood like this that is thicker than this, or this is the thickest?
No, there are other ones that are thicker than this. No, but they have different grades and different classes. There are some that are not even as thick as this. No, and there are some. It also depends on the type of jobs that I want to do.
Now, where I'm going, sorry to cut you short, where I'm going to is staircase. So imagine if we are doing like a 7-story building, is this the kind of thickness that I'm going to still use, or it doesn't matter?
Yes, we can.
Or it depends on the load distribution?
And this thing is a formwork.
Okay.
You understand?
Yeah.
And the function of this is to create the formwork. It's not like a permanent thing. After a while, you are still going to remove it.
Oh.
So it's not going to be.
Oh my word. I thought you were going to like cement it up.
No. The thing is that it's just going to provide like a base for us to pour the concrete of the staircase.
Okay.
After 20 days,
you remove it.
Then the staircase itself is concrete and steel that is there. they'll move on to the next floor. So it's not going to be a permanent.
So after you finish removing this, what would you use it for?
Like this one now is still going to be useful throughout this.
Another project?
Throughout this phase of this project.
Oh.
That's going to keep using it. That's it.
Okay. Now I understand. I understand what you're going to do. Once you remove it, you're using it for the next phase.
For the next phase.
Oh, I thought maybe there is like a provision of this for all the phase. So once you're done. So after you're done using it for all of the phases, what is this still useful for?
We can take it to the next project.
To the next project. Wow, is that durable?
It's very, very durable. That's why anytime we are working on any of our projects, we use this.
What's it called?
This is a marine board.
A marine board.
Yeah.
You know, it looks almost like one they use for all those furniture, all those modern kind of table.
Yeah.
But some of them don't last. Is this still the marine board or is it a different kind of marine board?
Something about this thing is I know there are different grades.
Oh.
They are different depending on cost too. And depending on how deep the pocket of the client or handling the project is. I know you understand.
Yeah, I understand.
What I'm trying to say. So when we introduced this to the client and we said this is the type that will give us what we want to work, we was able to get it. There are some situations that clients may not be able to. Okay, we can't get this. Definitely, we still get another one that will still give us what you want, but they may not last long as this.
Yeah.
You understand?
So we're at the back area, and I learned there's going to be a swimming pool here.
Yeah,
so looking at the soil area, looking at, I don't say soil texture, but I'm not sure, but it looks like a wet ground. Now a swimming pool is going to be there. How are you going to be able to control? I don't know if there's anything like that to control the water during the construction.
Yes, definitely. Right now, of the swimming pool area, we are trying to work on the base slab of the swimming pool. So while working on that, there will be pipes, proper drainage to ensure that any water around that side can go. There will not be accumulation of water around that side. And even before we even put the base slab there, before we even do the reinforcement work of the base slab, after our blinding, we are going to have proper waterproofing there to ensure that our reinforcement of the base slab is not affected by water. You know, this iron, once water is already entering iron, there's every tendency for it to start rusting. Definitely. So we are going to have so during the construction of the swimming pool, the full due diligence will be followed in terms of waterproofing, in terms of drainage, in terms of piping. So I are still in the preliminary phase of the swimming pool now. So we are still hopefully before we reach the first floor casting, we'll have gone far with the swimming pool.
Okay, thank you. And that was it with the site engineer of Realistic Projects. This is the Belmont project and it's a commercial building. We've heard a whole lot of things about casting, about the beams, about columns, about the different kind of iron casts that we have. Also the way columns are going to be held. He also mentioned about the piles and he mentioned about the ground beam. I'm sure you enjoyed this particular episode because it was a lot practical than any other kind of practicals that we've done. But we're going to be having subsequent ones and more practicals about things that we've discussed. However, for previous episodes, you can watch it on YouTube at Realistic Projects for inquiries. And then if you want us to handle any of your projects, construction, from building to real estate to designing, reach out to us on Realistic Projects on Instagram. My name is Favor Orok once again, and this is Realistic Projects.